Hey everyone, in this video, I'm going to be talking about what is called a cautionary tale for data science projects. This cautionary tale is a must know for every data science aspirant. Please stay tuned till the end of the video and it will be completely worth your while. I'm coming up with multiple videos on data science and machine learning, so be sure to hit the subscribe button and bell so that you don't miss out on any upcoming videos. I am Manjunath. Let's get started. As part of the data science project's cautionary tale, let us spend some time to understand what are some of the most important must check items for any data scientist to be mindful of and eventually addressing or remediating. Let's start with the first must check item: incorrect problem understanding. Does that ring a bell in your mind? This is fundamentally one of the most important critical dimensions that you look for as part of your cautionary tale. Why do I say that? I say this simply because if you do not understand the problem correctly, how you are expected to get an optimal solution for a problem. So it's imperative that you understand the problem for a given context as a function of the business problem and eventually translate that as data mining or analytical problem so that you will be able to embark on the data analysis to address certain business imperatives as part of the problem itself that you're trying to answer. Any guesses as to what could be the second item for must to check as part of cautionary tale? Don't you worry. Absence of baseline and measurable project and business goals. Does it ring a bell again in your minds? Why do you say baseline is very, very important? Let's just understand this. If you are expected to improve the profits for a client by 10%, you would fundamentally ask this question: tell me what is the current baseline? Let us say your client is at $10 million profit per year. Then you are expected to increase 10% profits through your model based solution. Then it makes sense to say the client is expecting you to help with $1 million per year increase in the profits over the current baseline of $10 million per year. If you do not have any baseline, how on earth you would be able to measure the differential performance as a function of the model based solution that you're trying to address the imperative with, or the business goal that you have in mind, isn't it? So very, very, very important to have the baseline and measurable project and business goals. Not just that, these goals have to be realistic in nature. Goals have to be quantifiable also. Otherwise, you will be in big trouble when you are looking at differential performance measurement. Moving on, lack of model metrics, yet another important dimension anybody would want to address and be wary of in terms of handling the projects. Why would I say that? I say that from my experience as a practitioner. When you lack the understanding of the metrics, or appropriate metrics are not identified, then you will not be able to measure. Simply, if you are not able to measure something, you will not able to manage. So you would be able to identify the set of model metrics for establishing the model diagnostics and model performance, lack of which is detrimental to data science project success, isn't it? What else do you think? Quality and integrity of data. By far, I would argue this is one of the most important dimensions which is in your bucket list. Quality is paramount. Quality of data and integrity of data is paramount. It's one thing to say, I have big data, I have voluminous data, but what is expected is the quality data, not the volume. Why do you say that? Let me say this emphatically. There is no correlation between huge volume of data, you may want to call that big data, and the insights that you derive as a function of data analysis always. So the volume of data doesn't have any bearing on the meaningful insights rather, if the data quality and integrity is questionable. You must have heard the saying, garbage in is garbage out. That's exactly what happens when you have issues with quality and integrity of data. As part of the cautionary tale, here is yet another important dimension that you should be concerned about, and that is called sampling bias. Let's understand what is the sampling bias I'm talking about with a concrete example. Let us just say you are going to perform a survey of high school students to study a phenomenon about certain banned substances for teenagers. Here, you may not have thought of considering, let us say, school dropouts and homeschool students. In this sense, your sample and consideration is biased because you have left out school dropouts and homeschool students from this survey. So, can you think of what could be the issue when you have sampling bias? Can you think of what could be the major issues when you have sampling bias? It's very, very important to understand this. Simply put, sampling bias could be problematic. Why do I say this? I say this because any statistical or data analysis you perform on the sample, which has inherently been biased in terms of sampling bias, would be systematically erroneous. Either it could lead to systematic underestimation or systematic overestimation of the corresponding parameter in the population. So, this is one other dimension that you should be concerned and should be wary of when you are dealing with the data science projects in general. Moving on, the last point, but not the least on this slide, is called multicollinearity. By the way, I've created an in depth, exhaustive video with loads of information thrown in into multicollinearity created for you for your consumption. I'm going to leave a iCard up there. Please feel free to watch it at your convenience. And there is wealth of information as to how do we address multicollinearity, how do we remediate, what are the consequences, etc. For now, I'll just say briefly this. Issues of multicollinearity poses several challenges. So let's just understand briefly what this multicollinearity is all about. Multicollinearity means your independent or predictor variables are correlated among themselves. In a setting when you are performing, let us say, multiple linear regression for predictive modeling, your predictors, if they are correlated, you will have issues with the coefficients eventually that you derive out of this ordinary least squares method for multiple linear regression. So what would happen is the coefficients of the multiple linear regression is used for providing quality advice to your clients strategically. In presence of multicollinearity, suffice it to say, the quality of the advice would suffer, and hence, as part of cautionary tale, you should be taking note of multicollinearity and subjecting that through the remediation process to alleviate the issues of multicollinearity. Please watch that video up there. So it's going to be very, very useful for you to understand and remediate multicollinearity. Continuing with few more must check items as part of cautionary tale. Here you go. One more important item in our list called confounding variables. Let's just understand what do I mean by confounding variable, what kind of issues it poses for analysis. So let me just make an attempt to define what is a confounding variable very, very intuitively for you. It is also called a confounder, also means a hidden variable. So this confounder is a variable which has an influence both on your dependent or target variable and your independent or predictor variable. It causes what is called spurious association. In fact, its confounding is more of a causal concept, and hence you may not be able to efficiently describe the association or correlations. Okay, so let us just understand with an example what does confounding variable mean. Let me say on a particular day 20 people walk into a mall and they consume 10 bottles of beverages. On another day, let me just say 10 people walk into the mall and consume 30 bottles of beverages. If you analyze the data closely, lower the number of people walked in, higher the number of bottles of beverages consumed. Sounds counterintuitive, isn't it? So, what is confounding has got to do with this example? Here it is. Did I say some time ago? Confounding also means hidden. What happened when 10 people walked in and consumed more beverages is the fact that that day outside temperature was quite high. That made less number of people consume more beverages as compared to another day more number of people walking in and consuming less number of beverages. Hope it makes sense. So what am I trying to say here? What kind of issues you would get into when you have confounding variables as part of your data science projects? Simply put, it could cause you to arrive at incorrect conclusions as part of your analysis. That's what the implication of compounding variables are. So you need to be very, very mindful of this fact. And anytime you encounter data science projects or embark on the journey of data science projects, you need to be looking at this very, very critically and closely as part of your cautionary tale. Let's move on and check out what else comes next. Voila, bias variance trade off. Realize in the world of machine learning, particularly in supervised machine learning, bias variance trade off is very, very critical and very, very relevant, especially when you are dealing with predictive modeling. Bias variance trade off is basically a way to diagnose the performance of an algorithm or a model by breaking down its prediction error. So let's just understand what is this bias and what is this trade off that I'm alluding to very briefly. Bias is basically an error which results from making an erroneous assumption in the learning algorithm. Keep in mind, high bias can cause an algorithm to miss out on the very relevant relation between features and the target output or the dependent variable. Basically, we are talking about underfitting. So let's understand what is variance briefly. Variance again is an error from sensitivity to small fluctuations in the training data set. When you have a model which has high variance, mean it can cause an algorithm to model the random noise over the signal in the training data rather than the intended outputs. So you're in a way talking about what is popularly called overfitting. So this is one of the important dimensions that you have to keep in mind as part of your cautionary tale. So moving on, here is one more, omitted variable bias. Remember, a minute or two ago, I alluded to what is called confounding variables. There is some connection between the two. Let me just explain. So when do you think omitted variable bias occurs? Think about it. Omitted variable bias occurs, let us say, when you are performing regression model development. When your regression model leaves out set of relevant independent variables or predictors from your model, which are otherwise known as confounding variables, you get into a situation of omitted variable bias. So what does this condition or this omitted variable bias do to you? So this kind of forces the model to attribute the effects of omitted variables to the other variables that are in the model. So what does it do? When you have attributed wrongly the effects of omitted variables to variables that are in the model, you are basically biasing the coefficient estimates of your model. So that's the consequence of omitted variable bias. And hence, as part of cautionary tale, you need to be careful about handling such variable bias in the model development. Here you go with one more, popularly known as overfitting. What do you understand by the term overfitting? Overfitting simply means the model that you develop on a particular data set, training data set, works exceedingly well on the training data set, but does a pathetic job of predictions on the test data set. Remember, model performance measures are established not on the training data set, but predominantly on the testing data set. What is the good of a model which does very well on the training data set but does a pathetic job of predicting on the tested data set? This condition is called overfitting. Any guesses what could come next? Yes, you're right. Underfitting. Contrast overfitting with underfitting. Underfitting simply means your model is performing very poorly, not just on the training data set, but also on the test data set. In the world of machine learning, where your model performance matters, overfitting and underfitting are a strict no. And thus, you need to be very, very careful and mindful of handling overfitting and underfitting of the machine learning models. So, moving on, model drift. Any thoughts on what you think this is? What you folks think this is? Model drift simply means it is drifting away, in a manner of speaking. it is not performing as expected. There is a deviation from the expectations. Could be due to overfitting, could be due to underfitting, could be due to bias variance trade-off, could be due to omitted variable bias, could also be due to confounding variables, and could be more. So use your understanding of the domain, understanding of the best practices of the model development, and arrest the model drift based on several measures of model performance. So these are some of the most important must check items on your to-do list for data science projects. So far, I talked about multiple aspects of must check items as part of a cautionary tale. Now is the time to see the business side of things, shall we? Let's understand the business impact. Due to the various issues I explained in the previous slides, you need to be worried and concerned about the business impact that the model is going to create. Why do I say this? Think about it. You as a data scientist is being paid to solve a business problem. So as part of solution to a particular business problem, creating business impact is imperative. What good is the model where you claim is the best in terms of the model performance diagnostics, but not able to create the business impact? Some of the cautionary tale stuff that I talked about could result in unintended business impact, and thus you need to be even more careful about how the model is going to perform when it is deployed in the production environment as part of your solutioning. Yeah, as part of this business impact, it should be resulting in intended KPI measures to be met for the organization strategically. Let us say your key performance indicator for an organization could be profits, cost, market share, revenue, etc. If you are able to meet part of this or all of these business imperatives in terms of the necessary business impact, you need to be mindful of the issues that models could have in terms of the cautionary tale that we talked about. So, why it is even more important is to say some of the cautionary tale stuff that I talked about could result in posing big challenges for you in terms of presenting limitations of your solution. So, it's imperative when you make business presentations to your client and stakeholders, you need to identify the limitations upfront that could be a function of some of the issues that we talked about already. So these are, I would add to the must check item list for you to be mindful of when you are dealing with data science projects. Cautionary tale, one more time. Business impact is the key. Meeting the key performance indicators satisfactorily is what is one of the biggest objectives for you. And in doing so, if there are any limitations that are encountered with, be upfront in communicating to your clients and stakeholders. I talked enough and more about the cautionary tale. We also brought in the business dimension as part of cautionary tale. So you may be wondering what could be the remediation, right? Here is indicative direction for you to work on. Let's get started with the remediation. First and foremost, domain knowledge. So realize there is no substitute for domain knowledge. Domain knowledge plays a major role in data science projects. Domain knowledge would enable you to identify issues with the data, quality of the data at stake, etc. So domain knowledge is paramount. So use your domain knowledge to arrest or remediate some of the issues that we talked about previously. So what else? Use the domain knowledge to convert a business problem to a data mining or a machine learning or an analytical problem. Is that enough? If we convert a domain knowledge, use the domain knowledge rather and convert the business problem into machine learning? No. Come up with realistic, measurable, quantifiable goals. Set always realistic expectations with your stakeholders. Stakeholder management is very, very key for successful projects. If you were to ask me, what are the two important dimensions for great success of any data science project? I would say stakeholder management, risk management, and setting realistic expectations with the client. Is that enough? Is there anything more to add in remediation? Certainly, there are a few more. Here we go. robust data collection, ensemble models. Robust data collection means you have thought about the data utility, data literacy you have, understanding of the data you have data management strategy in place, which is aligned with the business strategy, and you have essentially designed scientifically the systems to capture the data in a robust fashion. When you can anticipate what are some of the KPIs that you would want to track as a function of the data mining activity eventually as a business, you would be coming up with the robust data collection where you would be able to leverage, let me say, smart data for better business decisions. And this is strategic dimension. Ensemble models is the engineering side of things where you would be keeping in mind the cautionary tale that I talked about in the recent past and then addressing as appropriate as we go along as part of remediation journey. Is that enough? No. You should always have a very good governance model, particularly data governance. It is very, very imperative for you to have a data governance mechanism which ensures robust data collection, which allows you to set that realistic expectations with and without the data, more pertinently with the data, what you could do, what limitations you may encounter, etc. Data governance is paramount. Is there anything more? Here you go. Last but not the least, you have to get a buy in from stakeholders and baseline what you are going to do. Why is it important? It's important for you to manage the stakeholder expectations. If you do not baseline that expectations and get the buy in from stakeholders, what I'm trying to say, formalize the process, have a formal communication with the client in the form of getting the buy-in from all the stakeholders concerned and baseline. That is what you are going to be held against or held over. So you have to be very, very clear about this baseline. So these are some of the things I would think you need to be looking at as part of your data science projects, more so what I want to call a cautionary tale. I hope you have thoroughly enjoyed the video and found it to be quite informative. Thank you everyone for watching this video till the end. If you have not subscribed already to my channel Data Science Galaxy, please subscribe right away. You don't want to miss any upcoming videos, so hit the bell. Good luck and happy learning. This is Manjunath signing off. Bye bye and take care. I'll see you in my next video.